Hello everyone, welcome to this tutorial with the A1 Science Tutor. In this video we're going to treat how to derive dimensions of derived quantities. There are two kinds of physical quantities. There are the fundamental quantities and there are also the derived quantities. Now the fundamental quantities are just majorly three. We have mass, we have the mass, which has its dimension represented as m, and then we have the length, whose dimension is represented as L, and lastly we have the time, whose dimension is represented as T. So these are the three major and most fundamental quantities, physical quantities in physics. But there are many derived quantities because when you manipulate mass, length, time in various methods, in various ways, you are going to get to derived quantities. So how would you get the dimensions of those quantities? Because dimensions of quantities help you to be able to get the unit of those quantities you're talking about. So here are some three examples which we'll use to be able to teach you how to do this. So here is a question: derive the dimensions of the following quantities. The first one we see there is work. So we have work there. Now you cannot get the dimensions of these quantities without knowing the formula of those quantities, the formula for them. So when you talk about work done, basically the formula for work done is force times distance. Can you see that? Force and distance. But because force is also a derived quantity here, which we're asked itself, I think it's better for us to go there. But before we come to this force, we'd rather go first of all to the B part, which is the acceleration, just for you to be able to understand easier. Now if we get the dimensions for acceleration, then you can get the dimensions for force, and then to get the dimensions for work done. So what is acceleration? The formula for acceleration is velocity over time. Velocity over time. Now we know that velocity itself is distance over time taken. So this is all over time. So this is what it means. Now there is a principle in fractions that if you have a fraction such as this and the numerator is also a fraction, that denominator of the numerator goes down to meet the other denominator. So what is going to be is like this. Have distance over time multiplied by time. So that's what you're going to see there. So this is now going to be, distance is a physical quantity known as length. So that is now going to be written as length over time all squared. So that's what is there. So the next thing you need to do here is just to apply the dimensions for each of those quantities. So we have length. Length's dimension is L, and then the dimension for time is T, is squared there. So if you want to remove this fractional sign so that you have just LT, that means you need to introduce a negative in front of that power. So you have -2. So this becomes the dimension for the acceleration we're talking about. Now it's from these dimensions that you are able to get the units for that derived quantity. Hopefully you should understand that, and you need to seriously take note of this manipulation which we did here. We have this denominator coming down to meet the other denominator. So if you have A over B all over C, what should actually be is A over BC. So that's what happens for that. But if you have something like A over maybe B over C, then this denominator is the one that's a fraction. So you carry this denominator of the denominator up like this, and then what you should have is AC over B. So it's like that. So that's the answer for the acceleration. So let's see how to get the dimensions for force. We have C is force. Now the formula for force is mass times acceleration. That's the reason why you need to know the dimension. You need to know the formula for these quantities to be able to get the dimensions for them. Now the dimensions for acceleration had already been gotten. This is the dimension there. So now mass itself is represented as m. So we have m multiplied by L t raised to the power of minus 2. This is simply LT mLT raised to the power of minus 2. So this becomes the dimension for that case. So the last example under this is for work. So now that you know the dimensions for acceleration, you know the dimension for force, how can we now do that for work? So work is a force multiplied by distance. And distance is a length. So but the dimensions for force is mLt raised to the power of minus 2 multiplied by the dimension for distance. The dimension for distance, dimension for distance is length, which is L. So this is now going to be m L multiplied by another L and multiplied by t raised to the power of minus 2. So this now becomes mL so t raised to the power of minus 2. So this is the dimension for work done. So hopefully you now understand how to derive the dimensions of derived quantities. The major thing you need to know is always to know the formula for each of those quantities. Then you can derive the dimension for any kind of derived quantity that is given to you. Make sure to subscribe to my channel so that you can see another video which I'm going to upload about deriving the units of those derived quantities. And there are also other videos I'm going to be uploading on physics, and also in chemistry and math. So you do so well to click the notification button and subscribe to this video as well as like it. Make sure you drop any comment you have concerning this video in the comment section below. Thank you.